All right, so in our previous examples, we didn't have any charges to worry about, and all of our atoms had their kind of ideal bonding, right? Carbon had 4, oxygen had 2 with 2 lone pairs and whatnot. But this isn't always true, right? So for example, carbon doesn't always have 4 bonds, which is the same thing as saying 8 valence electrons. Sometimes it can have less, right? One big thing to remember, and I'll go ahead and start, is that our elements of carbon, nitrogen, oxygen, and fluorine, and for the most case, other halogens are not going to have greater than 4 bonds, but these four in particular never have more than 4 bonds or 8 valence electrons, right? They can never have more than 4 bonds or 8 valence electrons. However, they can have less. And so if you think back to Gen Chem about what formal charge is, formal charge was the charge on an atom, assuming all the electrons are shared evenly. And it's important to know formal charge because it's often the site of reactivity. And so formal charge is equal to the number of valence electrons on the neutral atom minus the number of bonds that it has minus the number of lone electrons. So for example, oxygen, we can draw our kind of normal oxygen here where it has 2 bonds and 2 lone pairs. And so if we think about the formal charge here, oxygen normally has 6 valence electrons in its atomic state. Here it's got 2 bonds and then 4 lone electrons, right? 2 lone pairs for 4 lone electrons. And if we do the math here, we'll see a formal charge of 0. However, oxygen can have other forms where it does indeed have a formal charge. So let's check out this one right here. Oxygen normally has 6 valence electrons in its atomic state. Here we have 3 bonds and then 2 lone electrons. And so that'll be a +1. And so this will have a positive formal charge. And so I'll just show you the most common motifs, and this is pretty much all that you're going to see. There are other ones, but they won't be very common in our course. And so again, this is going to be something that you want to memorize through practice. So here we've got carbon, right? Normally we have our 4 carbon bonds. It has a neutral charge. The other 2 instances are carbon with 3 bonds and then no lone pairs. This is what's known as a carbocation. So it has a positive charge because here it has 1 less bond. And then the other instance is carbon with 3 bonds and then a lone pair. Again, it just has 8 valence electrons here, so we're not breaking the octet rule. In this case, it has a negative charge. And so this is what's known as a carb anion. And those are the 3 most common forms of carbon that we'll see. Next up is oxygen, right? Normally 2 bonds, 2 lone pairs, neutral. Oxygen can also have 3 bonds and 1 lone pair, in which case we'll have a positive charge that we saw above. And then the other case is with oxygen with 3 lone pairs and 1 bond. In this case, it has a negative charge. So those are the most common forms of oxygen. And then finally, nitrogen, right? As we said, normally 3 bonds, 1 lone pair. The other common motif is nitrogen with 4 bonds and no lone pairs, in which case it's a positive charge. Nitrogen can have a negative charge, but it won't be as common. When it does have a negative charge, nitrogen will have 2 bonds and then 2 lone pairs. Notice that we're not breaking the octet rule. None of our compounds have more than 4 bonds or more than 4 valence electrons. Halogens, right? We learned 1 bond, 3 lone pair. The other form is when it has 0 bonds and then 4 lone pairs. So it's just kind of floating by itself in its ionic form. So in this case, it has a negative charge. And so we can take a look at some condensed formulas and then draw the Lewis structures. In this case, we're going to have some formal charges here. So here we have CH3OK. So we have a CH3, right, our carbon with our 4 bonds connected to this oxygen. And then here we notice that we have K, which is potassium, which is obviously a metal. And so we've got an ionic bonding situation, right? Remember that potassium has a positive charge. And so we need to fill out this rest of this oxygen so that it has an octet, has 8 valence electrons. And so we have 1 bond. That means we need 3 more lone pairs, which will give this oxygen a negative charge. Another common motif that you'll see is CH3, and then we'll see nitrogens with 4 bonds. So something like this, CH3NH3Cl. So again, draw our carbon, 4 bonds, 3 hydrogens. And then here we have a nitrogen, and now this nitrogen has a total of 4 bonds, right? 3 hydrogens, and then it's also connected to the carbon. In this case, this nitrogen then has a positive charge, And then there's nowhere else to attach the Cl, right? We can't attach the Cl anywhere because if we try to attach it to the carbon or the nitrogen, we'll have more than 4 bonds. That's a big no-no. We can't attach to hydrogen. Hydrogen is never going to have more than 1 bond, so we can't do that either. So in this case, it's just going to be a chloride. It's just floating off by itself, just a counter ion. And so again, this comes through practice, memorize through practice.